We have got some problems here that are based on zeros and roots of polynomials. Verify whether the following are zeros of the polynomial indicated against them. First one is px is equal to 5x minus pi, where x is equal to 4 by 5. Sorry, not where, but you have to check whether this x is equal to 4 by 5 is the zero of this polynomial or not. So what do? We take this value 4 by 5 and put at the place of x. So it becomes p 4 by 5 is equal to 5 multiplied by 4 by 5 minus pi. Let's take the value of pi as 22 by 7. 22 by 7. Right? So from here, this gets cancelled. And now you have 4 minus 22 by 7. And if you take the LCM, you get 28 minus 22. And this is 7. You get 6 by 7. Now clearly 6 by 7, you are getting the result as 6 by 7 and not 0. Therefore 4 by 5 is not a 0, because if it were 0, then this polynomial px would be equal to 0. Okay, so this is not a 0 of this polynomial. The next one is px is equal to x squared minus 1. First, let's check for x is equal to 1. So when you put 1 at the place of x, you get p1 is equal to 1 squared minus 1. That will be equal to 0. Now let's check for p minus 1. So for p minus 1, you get again minus 1 squared minus 1. Minus 1 squared means 1. So 1 minus 1 is 0. Now for both these two values of x, the polynomial becomes 0. That's why, yes, 1 and minus 1 are the zeros of this polynomial. In third polynomial, you have px is equal to lx plus m, and you have to check whether x is equal to minus m by l is a root of this polynomial or not. So p minus m by l, that is, if we put minus m by l at the place of x, then if it's a root, then this polynomial will be reduced to 0. So l multiplied by minus m by l plus m, right? So this l will give you 1. This is minus m plus m, and yes, it is equal to 0. That's why x is equal to minus m by l is a 0 of this polynomial. Now you have to check for two values, x equal to minus 1 by 3 and 2 by root. X is equal to minus 1 by square root 3, then 2 by square root 3. So let's first check for p minus 1 by root 3. So when you check for p minus 1 by root 3, that is, we put minus 1 by square root 3 at the place of x. So this becomes 3 multiplied by minus 1 by root 3 squared minus 1. This gives you 3 multiplied by 1 by 3. Why? Because it is of the form a by b whole raised to the power of m. This means it is a raised to the power of m by b raised to the power of m. In this case, your a is minus 1. So minus 1 whole squared means 1. Then at the place of b, you have square root 3. And square root 3 raised to the power of 2 means square root 3 multiplied by square root 3, you get 3. Then this is minus 1, and from here you get 1 minus 1, that is equal to 0. Yes, x is equal to minus 1 by 3. Minus 1 by 3 is the root of this root or 0 of this polynomial. Then you have 2 by square root 3. 2 by square root 3, it means that if we take this p 2 by square root 3, this becomes 3 multiplied by 2 by square root 3 whole squared, and this is minus 1. From here you get same thing what we have done here. So 3 multiplied by 2 squared means 4. Square root of 3 squared means 3, and minus 1. From here you get 3. 4 minus 1 is 3. 3 is not equal to 0. Of course, it's not equal to 0. That's why we say that 2 by square root 3 is not a 0 of this polynomial, but minus 1 by square root 3 is. Find the 0 of the polynomial in each of the following cases. Now, in this case, you have to actually find zeros. So first is px is equal to x minus 5. We know that whenever we have to find the zeros or roots, we actually equate this polynomial to 0. Now you have x minus 5 is equal to 0. It means that x is equal to 5. It means that at the place of x, if you put 5, you'll get 0. And you can check. 5 minus 5 is 0. The next one is px is equal to 3x. So px is equal to 3x. If you want to find the 0 of this polynomial, equate this to 0. And this becomes 3x is equal to 0. It means that x is equal to 0 by 3. It means that x is equal to 0. This is the root or 0 of this polynomial. Px is equal to cx plus d. C cannot be equal to 0. C and D are real numbers. Okay, of course, C and D can be any real numbers, and C cannot be equal to 0 because it's a linear polynomial. We have learned this thing that linear polynomial is given in the form of ax plus b, where a cannot be equal to 0. Same thing is here. C cannot be equal to 0. It means that it's a linear polynomial. C and D are real numbers. Now, real numbers are rational numbers, are irrational numbers, they are integers, they are natural numbers and all. So C and D can be any real number. Okay. This information is important, but when you have to find the 0 of this one, you will do what we have done here and what we have done here. That is, Px is equal to Cx plus D equal to 0. It means that Cx plus D is equal to 0. This gives you x is equal to minus d by c. X is equal to minus d by c is the 0 of this polynomial, and you can check it. Put at the place of x minus d by c. So c multiplied by minus d by c plus d, and this gives you minus d plus d, that is equal to 0, hence verified. Right? So minus d by c is the 0 of this polynomial.